Something you probably first saw pinned up in a classroom. The periodic table of elements.
Yeah, absolutely. It feels complete, right?
Totally. I mean, Dmitry Mendeleev laid it out back in 1869, put the known elements in order, even left gaps for ones he knew W had to be out there. It feels like the bedrock of chemistry.
It really is. I mean, one of the most elegant and powerful organizing principles in all of science. But what our sources reveal is that this familiar chart is surprisingly not a finished story.
Oh.
Yeah, it's actually full of fundamental questions, things scientists are still genuinely puzzled by.
And that's exactly our mission for this deep dive then. We're going to unpack these surprising enigmas hidden within the periodic table based on the material you've shared with us.
Oh, good.
We'll show you that even this cornerstone of science, from the absolute lightest elements to theoretical ones at the very edge, is still a frontier of discovery. Let's unpack this.
Okay, let's start right at that far edge then.
Yeah.
One of the most talked about mysteries in nuclear physics is this concept known as the island of stability.
Right. The super heavy elements, we know that elements beyond uranium, that's Z92, the SHEs, they're incredibly unstable. Their half-lives just get shorter and shorter, right? Often fractions of a second.
That's the general trend, yeah. Which makes synthesizing them incredibly difficult, as you can imagine. But nuclear shell theory predicts something interesting.
Which is?
That if you hit just the right combination of protons and neutrons, the nucleus might achieve a special kind of stable configuration. It's like hitting a magic number for both protons and neutrons.
Oh, okay.
So the theory points to atomic numbers around, say, 114, maybe 120 or 126, paired with neutron numbers around 184 as potential locations for this island.
An island where their half-lives could be significantly longer than their neighbors.
Exactly, longer. That's the idea, forming an island of relative stability in a sea of instability.
Okay, so the theory paints this picture, this stable haven out there. But what does the actual experimental evidence show so far? Have we even gotten close?
Well, that's really the core of the mystery. We have synthesized elements all the way up to 118 oganesson.
Okay.
But their half-lives are still heartbreakingly short. We're talking milliseconds, maybe seconds at best. We haven't seen anything that lives for minutes, days, let alone, well, longer.
So element 118 exists, but the island itself, it's still just theory based on what we've actually made and measured.
Precisely, yeah. The exact location, how long the elements there might truly survive, could be seconds or maybe something vastly longer, like minutes, days, even years.
Yeah.
And what their chemical properties would even be, are all open questions. Synthesizing and studying even these short-lived super heavies pushes our experimental capabilities to the absolute limit. The fundamental challenge is just cramming that many positive charges into one tiny nucleus.